course. Apologies if there's a bit of fan noise in the background. It seems like my computer is ready to take off. I do need to create a slightly better setup for audio recording. Hopefully I'll be able to do that in June of this year, so stay tuned for even cleaner audio. On some level, this conversation is lower key than a lot of the ones we had this past winter when there was just this onslaught of extreme weather repeatedly. But even though it's the spring and the weather is generally more benign, it's still been pretty unusual recently across much of California in that it has been unusually active still. Not unheard of. Sometimes April and May are wet months in California, but not always. In fact, not even often in a lot of parts of the state. So it's been notably cool, not record cold, but notably cool yet again, and also pretty wet and active. Again, there's been some additional precipitation. So we did get a pretty significant heat wave a little over a week ago, but it's once again cool. And damp in many places. Today, once again, there's some light precipitation in some parts of Northern California, and over the weekend there was some not so light precipitation in some parts of Northern and Central California, along with some significant thunderstorm activity. Yet again, as had been noted in a blog post from about 10 days ago, some significant Central Valley supercells, and then also 2 more LA Basin tornadoes. They're both very weak, but one of them was very photogenic, and there were some pretty spectacular videos in South LA, in the Compton area, of this funnel cloud touching down and becoming a tornado, causing some damage again. So I think that may make 3 or 4 at least tornadoes so far this year in Los Angeles County alone. All of them relatively weak, although one of them was an EF1 and caused significant damage. So that does happen from time to time, and California has essentially 2 miniature tornado alleys, if you will, one of which is across portions of the Central Valley, where there are convergent zones from low-level winds flowing in from the Delta and then veering north and south as they go into the Central Valley under unstable conditions, which occur periodically. The other one is the coastal plain in Los Angeles County, where once again the occurrence of mini supercell events and weak tornadic spin-ups has long been documented for many decades. And so those are the 2 places in California where you'd most likely expect to see, generally still weak, but tornadoes nonetheless. And that's where we've seen them this year. In fact, California has seen more tornadoes this year than states that typically see a lot of tornadoes in a typical season, including some of the states on the Great Plains and Tornado Alley have seen a low tornado count so far this season. And California is breaking those numbers. Now, I would expect that to change because peak tornado season in a lot of these places in the Great Plains doesn't occur until later in May or June, but it's always a striking statistic that I think surprises some folks maybe a little bit more than it should, because California does have a long history of tornadoes in these regions especially. So it is where we'd expect to see them, but of course it's always still surprising to some extent when any particular neighborhood experiences one, especially when it causes damage and is so well documented. The precipitation has continued. It's kept things green and fairly moist in Northern California, and it also slowed snowmelt this week. So the snow is still melting at a pretty rapid rate, but at a less rapid rate than it was during the heat wave, which did end up breaking a few records for heat earlier, late April. And it looks like the current cool and unsettled pattern will end. In fact, today is probably the last day of it. It'll be a little bit cool for a few more days, but drier. And then later this week, it'll be much warmer, even trending towards hot in a lot of places, especially across the interior. No record-breaking heat on the horizon, but perhaps a more prolonged period of warmer than average conditions. It may not dry out completely, though, despite the dramatic warming trend later this week, especially in the Sierra and in some other places where there could be some pretty unstable conditions with some thunderstorms at times. Mostly that's going to be in the higher elevations, but we'll see if they can drift down to lower elevations at some point. But this is a pretty different pattern. This won't be a low snow level, cold air, chilly condition pattern. This will be a warm pattern with some warm and unstable conditions over the mountains. So it will be noticeably different. Precipitation would be less widespread, and snowmelt will once again accelerate as temperatures warm considerably. And this pattern, by the way, this whole hemispheric pattern has been really weird in that California and parts of the Pacific Northwest have been cooler than average for a long time now. We've already talked about how this past winter was the coldest in some parts of California and Nevada in decades, and the spring has remained, despite the fact we have seen a couple of heat waves, on average it's been much cooler and damper than average as well. And this is a really striking divergence from the rest of the Northern Hemisphere, where there's just been record-shattering heat over and over again in South Asia, Southeast Asia, Southern Europe, and now it increasingly looks like the Western Canada. So British Columbia and Alberta are going to see another extreme heat dome event, not entirely dissimilar from what it saw that was so shocking back in June 2021. This one does not appear to be quite as extreme, and it won't bring temperatures that are as hot, but the societal impacts and the ecological impacts are probably still going to be considerable. There will certainly be record-breaking heat at the sort of the northern interior of the Pacific Northwest and in western and especially southwestern Canada as this extremely strong blocking ridge develops later this week into this coming weekend. This is partly what's going to bring on its southern fringe unusually warm conditions to California. They won't be so extreme here since we're really going to be on the far southern edge of this ridge, but it will still bring unusual flow pattern without that instability that I mentioned and warmer conditions. But the real extreme anomalous conditions are going to be up in BC and Alberta, where temperatures will be dramatically warmer than average, conditions will be dramatically drier than average, and that is actually very bad news up there because they're currently experiencing an extreme wildfire outbreak in Alberta. Major forest fires already ongoing, and this is really going to make them probably a lot worse, unfortunately. There were some things were extremely dry, and there were major wind events over the past couple weeks that got those fires really going. Now we're going to see a prolonged and potentially extreme heat wave up there. That's really going to accelerate the situation now that the wind has sort of created these elongated fire fronts, and now the hot and dry conditions are going to allow them to expand in other directions. That has indirect implications for the West for two reasons. One is there may be some increased inter-border demand for firefighting personnel over the next month or so. And also, these fires are producing a lot of smoke, and right now it's all headed up northward to the Arctic, but with a different flow pattern later this spring or early summer, it could end up making it further south, the west coast. So ironically, even though the early season fire risk is lower than usual in California this year because of the damp and cool conditions we've seen as of late, it's not inconceivable that there could be some higher elevation smoke coming in from Western Canada at some point if the wind patterns allow it. It's not super likely. It's more likely farther east, actually, along the Rocky Mountains and the Front Range, but it's not impossible that the West Coast could get some of that smoke if these fires persist for more than a couple weeks, as appears pretty likely at this point. So, not talking about fires, though, in California right now. It's just too cool and too damp, and so we are going to see a slow start to fire season. There will, of course, be some relatively minor grass fires as the grass starts to dry out a bit on warmer and windier days, but really the risk of serious fires right now is not very high. And I do think that the fire season at higher elevations this summer and coming autumn is likely to be milder than average. So we're talking 6,000, 7,000, 8,000 feet and above. There's just too much snow on the ground. It's not going to melt till late enough in the year that the soil is going to stay damp up there, and I don't think there's going to be a really large risk of major fires up above 7,000 feet or so anywhere, really. But below that, especially well below that. If we're talking below 4,000 or 5,000 feet, things are still damper than usual now. But there's been so much growth of brush and grass in these grassland and oak woodland and chaparral environments. So really anywhere where there's grass or brush or mixed grass, brush, and trees, there's been so much extra growth this year that by the time that does eventually dry out later in summer into the autumn, as we go into wind season and coastal heat wave season, there will be a lot more vegetation to potentially burn. So I'm not confident at all that this will necessarily be a mild fire season at lower elevations, where of course more people live, because there is so much extra growth. But it probably will be late, so I don't think we're going to see significant fires there in the next month or so. But come August and September, and depending how dry September and October are, perhaps into October as well, the lower elevations below 4,000 or 5,000 feet could actually see in some places an elevated fire season this year because of all that extra growth, depending on how hot we end up getting in July and August, and whether we get any major dry wind events in September or October before significant rain arrives. If, like last year, we get a nice early season rainfall event, it could really just decapitate fire season even at the lower elevations, and it'll be a mild year everywhere. But that's a big if, and if it doesn't happen, then it may be off to the races in August and September if we start getting those dry wind events with all this extra grass and brush at lower elevations. So it's an elevationally dependent fire season this year, and I also think it's going to be a late-weighted fire season everywhere. So the early part of the fire season is likely to be mild generally across California, and really a good portion of the interior Mountain West. The later part of fire season is likely still to be mild at the highest elevations, but may not be mild at lower elevations because of all that extra growth. Pacific Northwest, Western Canada, of course, an entirely different story, where the fire season really may start early up there and be worse than usual right from the outset, because it's been much drier up there, and it looks like it's going to be quite warm in the weeks to come. So different fire season we've seen in some recent years. Elevational complexity, geographic patterns are a bit flipped from some recent years. Stay tuned for that one. But I don't think fire season is going to be a big story for the next month or two in California, at least. Hopefully some good opportunities for some larger scale prescribed fires. Hopefully since environmental conditions are favorable, and hopefully personnel won't be too busy anywhere else fighting wildfires in the West, although I suppose the situation in Western Canada might distract from that a little bit. Alright, that's fire season, that's the weather to come. It's going to get warmer, but probably not extremely so over this week, and so folks who are tired of the cool weather, well, you're going to get a break, and it's definitely going to be warmer. In the long run, or I guess I should say, clarify what I mean by the long run, because of course there's different time scales of relevance that might be of interest. I mainly wanted to talk about El Nino right now, because this is something that is rapidly developing. It's getting a lot of attention in the media now, and that's probably going to continue, justifiably, I would say, because this does potentially look like it's going to be a big one with major implications globally. So I think it's worth starting to have these conversations episodically now, because this is, as usual, there's a lot of confusion surrounding even what El Nino is at a very basic level, and what kind of implications it might have. So where are we now? Well, ocean surface temperatures in the tropics are actually now, I think, warmer than average across almost all of the Pacific tropical ocean, all the way from the west coast of South America to the international dateline. Of course, it's most warm right along the South American coast, where water temperatures remain as much as 10 degrees Fahrenheit above average. Again, that is a very large anomaly for water, because it takes a huge amount of energy to increase the temperature of water by just a degree. So 10 degrees Fahrenheit is a lot of extra energy in the system. Right now it's maximized right along the coast of South America. Peru continues to see impacts from that, including heavy rainfall and coastal heat waves. But the Niño regions, the Niño 1, 2, 3, and 4 regions, including the famous Niño 3.4 box in the Pacific, which is the traditional way in which El Nino and La Nina are defined, the temperature anomaly in that box, is now significantly above average, and it's getting close to the threshold for a nominal El Nino. That's not too surprising, but what's more interesting is that it's rapidly rising, and there's almost unanimity at this point among dynamical model predictions that number, that Niño 3.4 number, is going to rise quite a lot more from where it currently is and remain quite elevated through autumn and probably next winter as well. So in other words, there is now growing confidence in a prediction that El Nino will emerge sooner rather than later and persist through next winter. Additionally, and I think more significantly, there is now pretty high confidence that this is going to be a major El Nino event. So this will be a moderate to strong, perhaps very strong El Nino event centered in the East Pacific Ocean. There is pretty high confidence in this. In fact, the range of outcomes for next autumn and winter now in the dynamical models that are most skillful is really from moderate to very strong El Nino. There really aren't any models at this point that are predicting anything other than El Nino, and there's growing consensus that this is going to be a big one. Potentially a big one up there with the largest events that we've measured in the 20th and 21st centuries. So this is going to be a pretty big deal, probably, in all likelihood. And the atmosphere appears to be aligning with the ocean. It looks like there's going to be a prolonged westerly wind burst over the next few weeks that's going to induce that sort of El Nino standing wave in the atmosphere that's so characteristic of a strengthening event. So really everything appears to be aligned. The real world appears to be cooperating with the models. The atmosphere appears to be coupling with the ocean. It looks like it's full steam ahead for a significant El Nino event. And this is more important. This is more relevant than it would be if there were just high confidence in a weak El Nino. I don't think we'd be having a very significant conversation about it right now, because the teleconnections, the remote weather impacts from a weak El Nino or a weak La Nina really aren't very discernible sometimes. It's not really clear that would have a major impact on regions outside of the tropics. But in the case of a strong or very strong El Nino event, there is really high confidence that will affect the northern hemisphere weather patterns in a fairly discernible way. And in California, that's really going to matter next winter especially. It might have some influence on the late summer coastal heat wave potential, but really all eyes would be on what might happen next winter in terms of precipitation, in terms of the enhancement of the subtropical storm track that it would likely bring, especially to central and southern California, but perhaps northern California as well. And again, lots has been made about how El Nino is in everything, and of course that's true, but if we see a strong or very strong El Nino event, that still is the singularly strongest predictive signal that exists in seasonal and subseasonal climate prediction at this point. There is no thing that could happen that would give us a stronger indication of what next winter might look like precipitation-wise than a strong East Pacific-centered El Nino event. That's just the reality. It doesn't mean that there's a preordained outcome of another wet winter. It doesn't mean that something couldn't come along and disrupt it. But it does mean that should this event evolve into a strong or very strong event, as now appears to be more than 50% likely, so more likely than not, then that's a pretty strong predictive signal for next winter, which is of particular interest because, as I mentioned last time, conditions this past winter were quite wet in some parts of California, and there is a large snowpack that remains. And there is flooding that is ongoing on some rivers and in the Tulare Lake Basin area in particular. And that inundation and that elevated soil moisture in the mountains might persist all the way through the autumn. So there might even be some hydrologic carryover, some hydrologic memory that carries over into next winter, which, if it's wet again, sets the stage for a faster hydrologic response next winter. Now, that's getting out there a bit. We're still in May. So we have a lot of time for things to change. But this is starting to get to the point where it's worth thinking about these things because everything does appear to be coming together at this point. So it could still get derailed somehow. Perhaps something else could influence. We never know. There's going to be another gigantic volcanic eruption that could affect the climate in one year. We never know if there's just going to be some extremely weird iteration of random variability that could throw off the El Nino teleconnection. But for now, it does look like there's a very good chance we're headed for an El Nino that's on the strong or very strong end of the spectrum, and that will probably have implications for precipitation next winter. It may also have implications for coastal heatwave potential, as I mentioned, later this summer, although there's some disagreement in the models right now regarding just how much the nearshore surface temperatures, ocean temperatures, warm in the months to come. It does actually look like right now that the temperatures right off the coast of California and the ocean will remain cooler than average, at least for the next 30 to 45 days, so through May and probably at least through much of June. That does mean that I do expect that once this pattern finally settles down a bit, there'll be plenty of June gloom and May gray, a pretty robust marine layer, and pretty cool temperatures along the immediate coast, as we've seen repeatedly in recent years. But that later this summer, there's some disagreement about whether El Nino might start sending some coastally trapped Kelvin waves northward, poleward, I guess, in this case, and that might inhibit that upwelling considerably and bring a rapid transition to warmer than average nearshore coastal ocean temperatures. There's disagreement about this, and honestly, we don't have great predictive modeling for something like that because it's happening at a pretty fine scale spatially, and this is a relatively nuanced oceanographic process, these coastally trapped Kelvin waves, which could locally inhibit upwelling. So I don't have a lot of confidence in the seasonal models in capturing this, honestly. So what's interesting is that this right now this potentially strong El Nino event may be unfolding in the context of a northern extratropical Pacific Ocean that is not necessarily warmer than average. And so this is sort of a negative PDO-like pattern right now with this cold arc of water along the west coast, but very warm water really everywhere else across the middle of the Pacific and then increasingly in the tropics. Would that have a different teleconnection for California conditions than it would if the coastal ocean was warmer than average right now? Perhaps so, although I still think that the effect of El Nino, especially if it's strong later this season, will likely win out. And will likely eventually warm nearshore ocean temperatures, although perhaps not to the same degree as it would have in a warmer state of the PDO. Maybe that's possible. For next winter's precipitation, it's a more interesting question. I still think if El Nino is strong or very strong and East Pacific centered, as appears pretty likely, it will likely overwhelm every other signal, predictive signal-wise, but it might still modulate the precipitation patterns a bit. But I would still expect, regardless of that, to see a strong tilt in the odds towards wetter than average conditions next winter in California if that strong East Pacific centered El Nino materializes. So I would have said about a month ago that's a big if. That's now only a moderate if, because the odds do appear to be rising and there does appear to be pretty strong consensus that El Nino will reach pretty high echelons by the fall or winter to come. I'm not ready to hang my hat on some predictions from some models of a record-breaking El Nino magnitude. That remains a bit speculative, but it's not outside the realm of possibility either. Another reason why that's interesting beyond California is, of course, El Nino does affect global climate quite significantly, including the likelihood of major heat waves and floods and droughts in different regions. But one thing it also does is it increases the global average temperature by a noticeable amount on a temporary basis. So given that we have global warming and that the global average temperature has steadily been rising now for over a century, this is really going to put an exclamation point on that. And a lot of the anomalous warmth, by the way, doesn't necessarily emerge in the same calendar year when El Nino peaks. It's likely going to peak just after the oceanic event peaks. So 2023 may or may not be the warmest year on record globally. In fact, I would say there's perhaps a slightly less than 50-50 chance that it would be, or even according to some estimates, it's relatively unlikely to be the warmest year on record, because we've seen so many other very warm years recently. But that 2024 is very likely to be the warmest year on record, once again breaking really all of our previous records during the observed period. So there will be a lot of global heat that emerges out of the tropical Pacific Ocean as this subsurface warmth materializes and surfaces, and the exchanges a large amount of that heat with the atmosphere, which then, of course, through the global circulation gets redistributed poleward. So poleward meaning, of course, toward the poles in both hemispheres. So that warmth will eventually spread out. By late 2023 or early 2024, I would expect that we'll be seeing global average temperatures that are at record levels once again, and that we'll see a lot of extreme weather later in 2023 into 2024 globally, with extreme heat waves and extreme precipitation events becoming more likely in certain regions, partly because of El Nino and partly because we will be seeing global average temperatures that are warmer than we've seen in our recorded history, in all likelihood, due to the subducted energy that was sequestered in the subsurface oceans during 3 recent persistent years of La Nina events, and a lot of that energy is all going to come out in 1 year. So global warmth to come seems to be another major headline that I think is accurate, given the long-term global warming trend combined with what could be a blockbuster El Nino event this year, liberating a lot of the heat that had been temporarily stored in the oceans over the past few years. So, interesting times from a global climate perspective, and then also probably from a regional extremes perspective as well, in the months to come, including all the way through early 2024. All right, so I'm going to pause for a moment and start looking at comments. Please feel free to contribute more as I go down the list. There aren't too many right now, so hopefully I'll be able to get to the ones that are here for now. First comment was about the heat wave in the Pacific Northwest, which I think I sort of covered in the beginning. It does look even more significant in southwestern Canada than in the Pacific Northwest, but this looks like a pretty extreme event, and synoptically it looks eerily similar to June 2021. Again, it's not quite as anomalous, but from a standard deviation perspective, it's still a 3+ sigma event. That's a big deal. Another big deal event. Not quite as record-shattering as that other event, but again, the implications are significant given that there's already a major wildfire outbreak centered right on the region where this is going to occur, so that's likely to get a lot worse. Odds of 2024 surpassing 2016 as the warmest year on record, I'd say very high. I'd say well above 50%, maybe 60 or even 70%. Odds of 2023 surpassing it are actually low, as I mentioned, but that changes a lot in 2024 because we don't have the legacy of La Nina in the first part of the year dragging us down anymore, and we have all of this extra heat coming from the lagged effect of El Nino that are likely to come out of the system at that point. What effects might El Nino have on the monsoon season? Honestly, it's not clear. We still don't understand the North American monsoon that well. It doesn't necessarily make the monsoon wetter, though. In fact, it can, in some cases, suppress the monsoon in some regions a bit. California is always a fringe question anyway. If we end up getting much warmer than average near-shore ocean temperatures, especially off the coast of Southern California, it might slightly enhance the monsoon a bit locally, or slightly increase the likelihood of remnant tropical cyclone rain events in southern and central California starting in about August or September and through perhaps October or November. That's a bit of an edge case, but it can be a significant edge case if it happens. So it probably does increase the likelihood of those sorts of events in Southern California especially, not by a huge amount, but by, any amount is notable given that the background odds are pretty low. So that could happen, potentially. Let's see, comment from David that precip versus SWE, which is snow water equivalent, in Southern Oregon has felt like a really big winter up there, and there's still a lot of snow in the mountains. So SWE up there is still about 150 to 200% of median. In Southern Oregon, that may well be true. Southern Oregon has benefited from some of the storms that California did, not quite as anomalously wet as the Central and Southern Sierra, but still a good winter for sure. I'm talking more about the lack of snowpack further north in Washington State and up into British Columbia and southwestern Canada. So this is more of a northern tier effect, especially where the season has been unimpressive and where conditions are going to be very warm for the foreseeable future. So this is less true in Southern Oregon, although it is going to warm up there considerably, so they'll be a little bit closer to the center of this next heat wave than California will be. David also follows up that the water year precipitation is more like pretty close to average, so average winter in terms of the absolute precipitation volume, but a colder winter and spring, which has kind of kept that snow water high. So that sort of explains a bit of the difference from California. Up there, it's just mainly that the snow has lingered longer than it would, even though the precipitation volume has been close to average. In Central and Southern Sierra, we got both. We got a colder than average winter and a winter that was exceptionally wet in absolute terms. So record wet in some parts of the Southern Sierra. So we got a very wet and also an unusually cold, at least by recent standards, winter that kept all of that stored as snow, really, up in the mountains. And I just reposted a tweet from Mike Dedinger on Twitter. You can refer to the vast majority of that water that was stored up in the Sierra as snow is still there. It has not melted yet. It is definitely melting fast, and a lot of the snow at lower elevations is now already gone. But that's, of course, not where most of the snow water actually resided. The majority of that snow water was up above 6,000 or 7,000 feet anyway, and that's where a huge amount of snow remains. So that Central Valley flood risk, particularly Tulare Lake and Tulare Basin flood risk, is going to continue to persist for weeks. And best estimates are still that in a lot of places, the peak snowmelt potential isn't until late May and early June still, so we still have a long way to go. Again, I don't expect to see lots of flooding on the rivers in the mountains themselves, or at least not serious flooding, but the real challenge will be how to operationally manage dams so that the inflow doesn't exceed the outflow capacity, or doesn't exceed the volumetric capacity of some of these smaller dams in the Southern Sierra, and then what happens downstream once all that flow reaches the Central Valley and the Tulare Basin in particular, where it doesn't really have anywhere to go but fill the basin up. So that's going to be an ongoing story as things get warmer again. A question from Eric. Largest El Nino in the past century? It's not completely impossible. It could be, but we don't have the ability to predict that right now, the actual magnitude of the event, other than to say that it is pretty likely that it will be a strong event, at least, and it's unlikely it will be weaker than a moderate event. That's about as much as I'm comfortable saying right now. Let's see. A comment from Rebecca. I'm glad that the explanation of groundwater recharge was helpful last week. If folks wanted to learn more about that, you can refer back to that session for sure. So thanks for the kind words there. Ron mentions as prescribed fire practitioners here in the Sierra foothills are facing a narrow window for spring burns. What is the prospect for moderate to high temperatures and relative humidity above 30% over the next 4 or 5 weeks? I'm assuming this narrow window comes from the fact that it's sort of an artificially imposed narrow window in some respects, so feel free to correct me if I'm wrong, but it's partly that it's not that the environmental conditions are necessarily forcing a moderate window, because it's probably been too damp and cool, frankly, in some places to do meaningful prescribed burning recently. But normally what would happen environmentally is that you then would just have that window appear later in the spring or early summer rather than having a narrower window. But of course the challenges are, for practical and regulatory and personnel availability reasons, you can only do this so late into the summer in a lot of places because of different rules and regulations essentially, and the fact that a lot of the personnel who would work on those prescribed burns then become committed or occupied to wildfires, uncontrolled wildfires elsewhere by that point in time. That's my understanding of what that constraint is. But the specific question is sort of what is the prospect for moderate high temperatures and higher relative humidities. I think actually there's a decent window might be coming up starting later this week in particular, where things are going to dry out considerably, warm up considerably. Not totally sure what the relative humidity will be, although I do think there's going to be some certainly morning and late afternoon windows where the relative humidity is a little bit higher. So I don't think this is going to be an extreme low humidity event or anything. So I think there'll be some good windows coming up in the next, starting in about 3 or 4 days, and then continuing, through at least the next 5 or 10 days thereafter, where it'll be significantly warmer but not extremely dry and not super windy. Hopefully that'll give some good windows. It's harder to say going out 4 or 5 weeks, but it will stop raining eventually, and so that constraint of being too damp in some spots will probably go away. The places where it's least likely to stop raining immediately are the high Sierra. There still could be some showers at times in the foothills, but it is going to be drying out, warming up, but probably not too dramatically so. So I think there should be some good windows in there. That would be my guess. Let's see here. A question, could El Nino cause summer in San Francisco to be less foggy or windy, or would the warmer coastal California temperatures be more focused in Southern California? It's a good question. The answer is it depends. During strong El Nino events historically, we have actually seen warmer than average temperatures creep all the way up, inhibition of that cold water upwelling all the way up into central and northern California. This is, we see these tropical fishes make it as far north as the Bay Area sometimes during these strong events. But that might not happen until later this summer, and so I think it's going to happen after peak fog season anyway this year. So I think May and June, probably not. It's going to be cool and foggy, maybe even more so than usual in a lot of California. Later this summer, as I mentioned, in late July, August, and September, that could change, and it may change pretty dramatically, where the fog might just vanish as ocean temperatures warm up a lot. And they might do so a little bit earlier than usual, or to a greater extent than usual, but it is true that the most likely place to see warmer than average temperatures during a strong El Nino event would be in Southern California ocean, but with a strong enough event, that would probably also affect Central and Northern California. So we're just going to have to see about that, but I don't think it's going to save anyone from May gray or June gloom this year. I think that this would happen later. This is looking like it's something that wouldn't start until July or August. A question from Justin. Any likelihood of back-to-back El Nino years after the triple dip La Nina? That's an interesting and good question. The answer is I don't know. It is physically possible. We haven't seen a lot of them. They probably wouldn't be back-to-back strong events because you just don't have necessarily enough energy in the system to sustain strong El Nino for 2 years in all likelihood. I guess I would never say never, but I would guess that if there were back-to-back El Nino events, that the second year would be weaker, but it would still be notable, certainly from a global temperature perspective and from a marine fisheries perspective, to have 2 years in a row. So it's not impossible, but we have essentially zero ability to predict that far out right now, so that would just be guessing on my part at this point. A question from Fred about hurricane season in 2023, given El Nino. Obviously, hurricanes generally do not affect the west coast of North America, north of about the southern tip of Baja California, although Southern California can occasionally be affected by the remnants of such systems, so there's a little bit of a correlation. I suspect the question actually refers more to the Atlantic hurricane season, which is always of such interest in the United States because it affects anybody living on the eastern seaboard or the Gulf of Mexico seaboard. This year, normally El Nino suppresses the Atlantic hurricane season to a large degree because it increases the amount of vertical wind shear, which is unfavorable for the formation and intensification of tropical cyclones. However, this year, since the oceans are record warm in a lot of the Atlantic Basin right now, so literally the warmest they've been in recorded history, it's kind of a mixed signal. There might be increased wind shear due to El Nino, but then the ocean surface temperatures, which are fuel for hurricanes essentially are extraordinarily warm. So that's a bit of a mixed bag. And so it might be the case that there could be El Nino may end up suppressing the number of storms, but in windows where there's weaker shear, at least briefly, we could see really intense storms pop up. And whether or not those become a big problem and make landfall in heavily populated areas is anyone's guess at this point. So I'm not a hurricane expert per se, but this year is a bit more complicated than the usual El Nino prediction because the oceans are so record warm in the Atlantic right now that it's not totally clear what the effect is going to be on hurricane season because you have these two competing factors. El Nino is going to contribute more wind shear, but the record warm oceans are going to increase the potential maximum intensity of any storms that do form. So big question mark there, and I think it's going to be interesting to see how that evolves. But again, I'm not a hurricane season expert, for better or for worse. A couple of questions that I actually don't have good answers to right now, so I won't address them, but I might take a closer look and talk about them in a future session. One of them is about the effects of El Nino on the weather in the Pacific Islands, Hawaii, and Central America, like Costa Rica. Well, in general, some very general things. In Hawaii, I think there's a slightly increased likelihood of tropical cyclone landfalls because the eastern tropical and subtropical Pacific tend to be warmer than average, and so there's more eastern Pacific hurricane activity than usual. So they might slightly increase the odds of a central Pacific hurricane getting sort of moving westward from the East Pacific into the Central Pacific Basin and affecting Hawaii due to the warmer temperatures. I don't know for sure. I can take a look at that. For Costa Rica, the more tropical continental location, I think it probably increases temperatures because the Pacific side of the ocean at least would be warmer than average there. I don't know beyond that, so it would probably there's probably a bit of an increased rainfall signal, but again, I'm gonna have to take a closer look at that. I don't know exactly. I don't have necessarily encyclopedic knowledge of the country by country impacts of El Nino, but I can definitely take a look at that, talk about it next time or some future El Nino session. Another question relatedly about winds and El Nino. Are the Santa Anas more prevalent during El Nino conditions? That I think is less clear. I don't think there's a strong signal, but I need to double check there. So let's keep that in the I don't know territory also, and then I need to take a look. Let's see, a question from Randy. With passing time, how quickly do you see climate modeling and ensembles of climate modeling to improve due to improved tools? Are you able to participate in model development? I'm less directly involved in model development. I'm more on the model user side, although I keep up to date on what's going on in the model development world. I think that seasonal prediction is hard, but it's also a different problem than long-term multi-decadal climate projection. I've talked about this before, how weather forecasts are almost exclusively a deterministic initial condition problem where you need to know the initial state of the atmosphere, the ocean, and land surface really well to make any predictions. Seasonal predictions are a weaker version of that initial condition problem where you need to know the initial conditions, but there's a much wider range of outcomes that can plausibly come from those even precisely known initial conditions. And then for climate predictions over decades or centuries, it's an entirely different kind of question where it almost doesn't matter what the weather looks like today or what the configuration of the oceans is today, but a few decades from now, it matters mainly how much, the external forcings, how much, what's the concentration of greenhouse gases in the atmosphere is really the main thing that matters decades out, because we're not trying to predict any specific year anymore. We're trying to predict overall conditions over multi-decadal periods, and so those initial conditions become dramatically less important, ultimately approaching zero importance out at those time horizons, but those external forcings like greenhouse gases in the atmosphere become tremendously important, or aerosols in the atmosphere are also important on those kinds of timescales. It's those middle zones, 2 to 10 years out, where kind of both things are important, and we call it the gray zone because we don't have any good predictions in that gray zone, because we lose almost most of that initial condition predictability that we have at shorter time scales, but we don't gain enough predictability from the external forcings to overcome just random internal variability during that 2 to 10 year window. So we sort of have great weather forecasts, sort of okay subseasonal predictions, and conditionally skillful seasonal predictions, like if we have a strong El Nino event, but then we can't really say anything about the year after, and we can't say much about the next 5 years to come after that. But then we start to get some skill again out on 10 to 20 year timescales and more again beyond that, simply because the problem has changed, and it no longer depends so much on the initial conditions, and it depends more on Now, of course, there's uncertainties there for a lot of reasons, one of which is we don't know what the future concentration of greenhouse gases is going to be decades from now, because that depends largely on what we humans do as a society between now and then to mitigate the emission of those climate warming compounds. But this is one of the challenges, is that there's different uncertainties on different timescales, and that the problem is a structurally different prediction problem for long time scales versus short time scales. So it's a long way of saying that yes, things are getting better, but we are running up against some challenges where we really need models at this point that can depict the complex relationships between the ocean and the atmosphere, and also the land surface and the biosphere and the atmosphere, and the lower atmosphere and the upper atmosphere, so the troposphere and the stratosphere, better than they currently do. People are working on it. Models are becoming dramatically more complicated and sophisticated, which also makes them harder to work on and harder to interpret, because no one person knows how to operate all components of these models, because there's millions of lines of code. This is not something that one person or even one team of people can manage on their own. So as these models get better, they also get more complicated, which makes it harder to understand sometimes what's going on under the hood. So it's a bit of a mixed blessing there. And these models just have become remarkably sophisticated, but also remarkably complicated in a lot of cases. Let's see here. Any further follow-ups here? Well, it looks like I've covered most of what came today that I'm able to actually answer at this moment. One thing I thought I would add at the end is, if you were paying close attention to the Weather West comment section or my Twitter feed, is that I can now announce that I can't believe that I have, I feel like a regular old YouTube influencer, but I have the pre-orders are available for my extreme weather and climate calendar via Workman Publishing. The first calendar is for 2024, and then we're working on the 2025 calendar right now. So there'll be at least a couple years of this, and it does, of course, contain extreme weather and climate trivia that I think folks will find interesting. But it also includes a lot of process-based explanations for kind of the stuff we talk about in these calls and these conversations on these sessions, as well as on my blog and as well as on Twitter. So some cool weather facts, but also hopefully some shorter than 100-word explanations of things that are sometimes kind of hard to distill into bite-sized pieces. And so some of these entries took more time than others to create. So I hope folks enjoy it. I'll try and add a link directly to that in the video after I end it, so you can take a look for it there. Or I'll be probably posting again about it later. There's links on the blog. I'll share. It's pinned to Twitter. Plenty of ways to find it. Excited to hear what folks think about it. Sort of, instead of writing a full book, although honestly it turned into essentially a book-length manuscript. If you think about it, you got to write 100-word entries for most calendar days of the year, each year. It adds up, so there's a lot of good stuff in there, hopefully. All right, well, I think with that, I'll end it. Thanks again for joining, everyone, and I will probably see you at some time next week. I am sort of favoring Monday mornings for these sessions recently. That's likely to continue, although the exact hour will bounce around a bit. And I'll try and do some at evening occasions, just so that folks who can't join in the morning can join live periodically. And yeah, hopefully folks get to enjoy the, unless you're immediately downstream of this huge snowpack in the Sierra Nevada, the weather's going to be really nice. So hopefully folks are able to enjoy it as it happens, and be grateful that you're not at the epicenter of the big heat wave up in southwest Canada that's going to be unfolding over the next week or so. Just be on the southern fringe, and it'll be somewhat warmer than average. All right, everybody, I will talk to you next week.